Hi friends, this is Santosh from Tripoli. Today we will discuss about the RL transient response of RL series circuit. Transient response of RL series circuit. Resistance, inductance. This is voltage, DC voltage. This is switch T equal to 0. This is resistance. This is inductance. I of T transient response of series RL circuit. From the figure, first initially switch is opened at T equal to 0 minus switch is opened IL of 0 minus equal to 0, IL of 0 plus. This is initial conditions for all T greater than or equal to 0 plus. Switch is closed. Now we find I of T. Apply the KVL on this circuit. Becomes the equation becomes R into I of T minus L into di by dt plus V equal to 0. R into I of T plus these two move to RHS side. This is same position LHS. So equation becomes di by dt equal to V. So from this divide with the LHS RS both sides with R. The equation becomes I of T by L by R di by dt equal to V by R. I of T move to this side, L by R di by dt equal to V by R minus I of T. Now do the variable separable method. I of T by V by R minus I of T equal to this move to this side, it becomes R by L dt moves this side, so it is separated. Now integrate on both sides. So integration of di by V by R minus I of T equal to integration of R by L dt. So we know that integration of the 1 by x means log x. So here do internal derivation, internal derivation. So it becomes log V by R minus I of T. Do internal derivation by V by R constant 0, I of T 1, here minus R, so minus 1. I will write the front of the log equal to R by L. Internal derivation R by L, this is R by L is constant, move to integration beside, and 1 dt derivation integration is T. Here some constant K is here, some constant K occur. So we find the constant K value. Now apply the initial values to get the constant K value. So apply the initial conditions. Here initial conditions, IL of 0 minus equal to 0, IL of 0 plus. Here I of T value is 0, T value also 0. So K becomes minus log V by R. Assume this is equation 1, this is equation 2. Apply substitute equation 2 on equation 1. So equation 1 becomes minus log V by R minus I of T equal to R by L T minus log V by R. So from this we move this log into this side, it becomes positive sign, log V by R minus I of T, V by R minus I of T minus log V by R. This move to this side, so it becomes minus R by L T. So we know that log A minus log B, that is basic formula, log A by B. Substitute on this. So becomes V by R minus I of t by V by R equal to minus R by L t, minus R by L t. Now log moves to the side, log becomes exponential, V by R minus I of t by V by R equal to e to the power of minus R by L t, R by L t. Now V by R minus I of t equal to V by R e to the power of minus R by L t. We want I of t in positive. So move I of t in this, move I of t into this side, move this into this side. So equation becomes I of t equal to V by R minus V by R e to the power of minus R by L t. This is required response, required I of t. Now we want the voltage across the resistance and inductor. So voltage across the inductor, we know that formula, v r of t, vr of t equal to I of vr of t equal to I of t into R. We know we derived I of t value, substitute vr of t equal to v by r minus v by r e to the power of minus r by L t into R. Equation becomes v minus v e to the power of minus r by L t, r by L t. This is vr of t value, vr of t value. We want VL of t value also. We know that voltage through the inductor formula di by dt. We know the I of t value. Substitute d into d by d, L into d by dt of v by r minus v by r e to the power of minus r by L t. From this L constant, we move back. Derivative of this part is v by r is constant. Constant derivative, we know that 0. So this v by r also constant. V by r, derivative of e to the power of x, e to the power of minus r by L. Two internal derivative must and should. Internal derivative of this r by L. Here minus, here minus, we get plus. Here L cancel, here R cancel. So equation becomes minus plus v into e to the power of minus r by L t. This is VL of t. This is VL of t. L of t. Here constant, time constant is in time constant for R, time constant for RL series is L by R seconds. L by R seconds. Remember this one. This will ask into 1 mark questions in R22 regulation, R18 regulation, and even this is 1 mark question in ECA-2. 1 mark question in ECA-2. It is asked by what is the time constant for RL series circuit. We write the L by R seconds. Okay. Thank you friends. Please subscribe and like to my channel for more videos.